Hello dear students, as you know that yesterday we had taken up a session on a full wave rectifier which was a center tap transformer, and we have seen how we are getting a DC output signal. So a perfect DC signal was not obtained as we have seen in the last session, so we have to smooth out the AC ripples present. So in yesterday's session we have seen we had a step down transformer, then we had a rectifier made up of two diodes, and finally we had a load. So there was no filter section used here. So the output what we received yesterday, as we have seen, during each half cycle the diode was conducting or it was remaining reverse biased, and we had got a pulsating output. So in order to get a perfect DC signal now, we have to make use of a filter circuit. So there are various filter circuits available. One of the most important is the capacitor filter. These filter circuits, can you see here in this diagram, this capacitor filter, it is also called a smoothing circuit because it smooths out the AC ripples and provide a perfect DC. So let us take this section. Instead of taking a center tap transformer, let us take a bridge rectifier, because even this is a full wave rectifier. Instead of two diodes, we are now having four diodes. So diodes D1 to D4, again these are the PN junction diodes. As we have seen yesterday, the diode is a unidirectional device which conducts only in one direction, that is forward bias. So as usual, we are having the main AC input signal, which is 230 volt here, 50 Hz standard signal. So now the four diodes are connected in the form of a bridge, hence the name bridge rectifier. So D1 to D4 are connected in this manner, and now we are having the load as usual. But before that, now we are connecting a filter, which is a capacitor filter. So again, during the positive half cycle of this input signal, end A of this, or if we are not using a transformer, we can use directly AC signal here. So during positive half cycle, diodes D1 and D2 becomes forward bias. As you can see here, this end of the diode is P material and this end of the diode is having P material. So these are connected to the positive terminal of this signal, and the other end is connected to the negative terminal of the battery or the AC signal. Therefore, diode D1 and D2 becomes forward bias, whereas you can see diode D4 and D3, they are connected to the negative terminal of this supply. Therefore, D2 and D4 and D3 becomes reverse bias, and these two diodes does not conduct. So only diode D1 and D2 conducts. Therefore, when these two are conducting, they are forward bias. The current starts flowing in this direction. You can see here the green arrow mark, which is shown here. It comes like this and flows through D1, and through the load it goes, and through the capacitor, and completes D2 this cycle, and hence we are going to get this output. The dotted line what you can see here is the pulsating output. But now we have introduced a capacitor filter which smooths out. So during this period of positive half cycle, the capacitor C starts charging, and as you know that the capacitor C starts charging towards the maximum voltage whatever you are applying. So maximum voltage here, so capacitor starts charging as you can see here. So as it charges, the next cycle, that is a reverse bias, that is the next half cycle appears, and hence the capacitor starts discharging. And as you can see here, from this point the capacitor actually starts discharging towards ground here, but it will not discharge towards the ground because the next half cycle again appears. Can you see from here? It again appears here. By the time this capacitor discharges in this direction, the next half cycle appears, which causes the capacitor to charge again. Therefore, again it goes to the peak value, and in this way it continues. Now you can see here, we are going to get a waveform with capacitor filter. So during the negative half cycle, D1, D2 which was conducting now becomes reverse bias. You can see now here, this end has become negative, this end has become positive. Therefore, D2 and D1 becomes reverse bias, but now D4 and D3 has become forward bias because this is positive. Hence these two diodes conduct. So now the signal starts flowing in this green arrow mark which is shown here. It goes through D3, then through the load, it comes like this D4, and then completes in this direction. Hence again there is a pulsating output, but the capacitor always charges and discharges. So the period is, during one half cycle the capacitor charges to the peak value, and then during the next half cycle as it discharges, the next half cycle appears again. Therefore, again the capacitor charges to the peak and again it discharges. Again the next half cycle appears, and hence in this way we get the ripple voltage. You can see here this arrow mark, the capacitor charges. So this is the charging path, this small one is the charging path, and this is the discharge path here. Therefore, we are again getting an output where the output is not a perfect DC again. Thus, to get perfect DC, which is a straight line, we have to connect 2 to 3 smoothing capacitors. Thus, by connecting more number of capacitor filters, this output, the ripple what we are going to get at one stage becomes a straight line, and hence we get a perfect DC. So we can very easily get the pulsating output, the output which is a pulsating one. From there we can generate the perfect DC by using capacitor filter. In the same way, we can use a inductor filter, or we can use a combination of inductor and capacitor, which is known as LC filter, or we can use a pi filter. So I think the pi filter filters out much faster compared to the capacitor filter. Hence, the output will be a perfect DC at one stage. Hence, this is the basic operation of bridge rectifier with filter. Hence, by connecting filter, we get a perfect DC at the output. Hope you have all understood the basic operation of this. In the next section, we are going to consider how this output voltage remains constant, and the main element used for this is the Zener diode. Thank you.